Okay, I see we're being recorded. Okay, formalities out of the way first. My name is Chris Hanrahan. I'm the owner of Techris Power Electronics since inception. This is our 30th year. We're very proud of our accomplishments, and I personally have approximately 43 years of experience in static and rotary power conversion with some very large manufacturers, including Honeywell and Safran, who is a French manufacturer. I am FCC licensed elements 1 and 3 and formerly ABYC certified. I just don't pay the fees anymore, but I install and design per the ABYC standards. My store and business are located in Point Pleasant, New Jersey. We are at the top of the Intercoastal Waterway and very close to Manasquan Inlet. Thank you very much, Peter, for inviting me here, and it's a pleasure to see you all. We got a nice crowd there, and I appreciate you taking the time and listening to me. And our goals today are to share my experience, but also discuss some of the important aspects of a power conversion system and storage, energy storage systems on sailboats and powerboats, of course. We'll discuss several categories. Mainly, we'll start with batteries and your energy storage system, charging sources from alternators, battery chargers, solar, amp hour counters, the importance of monitoring your battery capacity, especially when it comes to lithium batteries. Then inverters, inverter chargers, important installation tips, and also shore power, 120 volt, 30 amp, 50 amp split phase. We'll also discuss galvanic isolators and isolation transformers. The brochures I sent are extremely informative, especially the Wiring Unlimited, tremendous source of information, everything from basic Ohm's law to installation, but very, very informative. I suggest you hold on to it and refer to it if you're doing installations yourself or you're looking for more very technical information regarding installing everything from batteries to inverters. It also discusses the shore power notes regarding including, I guess, galvanic isolation as well as isolation transformers. But a very, very handy brochure, and I encourage you to read it and refer to it when you have questions. There's certainly something to be said regarding referring to the manuals. All these products have very, very in-depth manuals. The Victron website is extremely handy. Maybe we can share the screen when it comes to discussing some of the installation manuals. But again, the Victron website, I cannot say enough about using it as a resource for design. They have schematics. They've got, of course, dimensions, specifications for every device. As with most manufacturers, their manuals don't come, their complete manuals don't come with the products. They give you a QR code, and you go to the internet and you can see all the information on their website. Read the manual, as you've heard other people say before. There's lots of information in there. Will certainly help you when it comes to questions and issues regarding your installation. So we'll start out with the foundation of your electrical system, and that is your energy storage, your batteries, and of course the main battery types are lead acid, that being flooded, gel, and AGM, and of course lithium batteries, which are all the rage due to their great performance and the ability to cycle thousands of times as compared to lead acid batteries, which you're lucky you get 500 or 600 cycles at 50% discharge. When it comes to lithium batteries, the main concerns are safety. I cannot stress this enough. There are several types of batteries, two types mainly. One is internal BMS, and the other is an external BMS. Victron Energy has both types. An external BMS, BMS is battery management system. Battery management system monitors the battery and feeds this information to a controlling device, whether it be again inside the battery or external. The controlling device being either a solenoid or a bank of transistors, allowing the current to go in and out of the batteries. The parameters that are being monitored by the BMS are, most importantly, the temperature, over temperature, under temperature. Lithium batteries cannot be charged below freezing, below 32 Fahrenheit. And most BMS manufacturers will be very, very conservative and not allow charging below 40 degrees Fahrenheit. The reason for this is the batteries become unstable, very hot, and in those cases you do have the risk of fire due to temperature runaway. And this is what all the UL standards address when it comes to lithium batteries is thermal runaway. That is the main concern. A good BMS and a properly designed BMS will prevent this from happening. The monitoring of the cell temperatures, the balance of the cells, voltage, of course, over voltage, under voltage, and will control the ability of the battery to charge or discharge. You can discharge batteries down to 0 degrees Fahrenheit, but the current will be curtailed as you approach that lower temperature. But charging, again, never below freezing, and you certainly don't want to be near that. Again, it's the BMS's job to protect that and protect the cells from any chance of thermal runaway. I personally have never experienced thermal runaway, nor have anyone I've sold to and I haven't heard of a thermal runaway of lithium iron phosphate batteries. There are different chemistries, but lithium iron phosphate is the main chemistry that you'll see that lithium batteries are marketed towards marine applications. The worst thing I've seen when it comes to lithium batteries is the over discharge. Over discharge of these batteries, what happens is they'll just die, and they'll, just like if you have a cordless lithium drill, they just shut off. And so if you over discharge them, sometimes it can be difficult to bring them back. It can be a nuisance, and that's where it is imperative to have a good BMS and monitor your batteries and prevent over discharge. Again, it can be a nuisance bringing them back. I have experienced that with customers, and sometimes the batteries have to be sent back and charged very, very slowly to bring them back to a usable situation. And that is the main question I get when I do boat shows or things like this, events like this, is the safety of lithium batteries. Uh, as long as they're installed correctly and you take the proper precautions. Installation, you're not going to put these in an engine room. Just too warm. Proper installation and obeying ABYC and Coast Guard regulations. Proper fusing. Every lithium battery must be fused. But taking the proper precautions, and you can have a very, very productive system that will last thousands of cycles. And this is where lithium batteries are they will outperform lead acid batteries. You'll get 10 years out of a
There we go. All right, we're back.
Okay. I was droning on about lithium batteries. If I didn't mention this already, the keys to all of this is safety, and I'm keying on lithium batteries because it is a main concern, and it's usually related. The concerns are related to inexperience and knowledge about batteries. I'll end the discussion with lithium batteries and the safety right now just by saying the being informed and having a good design system, a well-designed system, and being familiar with the product will go far in your enjoyment of and understanding, as well as the safety aspect. It's being familiar with it goes very, very far. I don't have a concern regarding safety after I do installations, and I've done many because I'm confident of the installation and having proper safety and disconnect capability and a good BMS. There are lots of manufacturers that make lithium batteries, and a lot of them will communicate with the Victron systems. You don't have to go with Victron batteries. With a Victron system, Victron inverters, the shunts, etc. Anything that has Bluetooth, and quite often they have got connectivity through the VE CAN, Victron Energy CAN bus system. So there's lots of options. Any questions about before I move on? Any questions about lithium batteries? Not right now. All right. Just raise your hand if you want to ask a question.
You speak to AGM batteries a little bit?
I can't hear you. I'm sorry.
Can you speak about AGM batteries?
Still can't hear you. I'm sorry.
Chris, he wants to talk about AGM batteries.
Okay, go ahead.
You want to know if you could? You want to know if you could talk about AGM batteries?
Okay, sure. AGM batteries have.
Hold on one second. We got a lithium. All right, so we have a lithium battery question first. Go ahead, John.
Can you tell us the temperature range for a lithium battery? You say you don't want to install it in an engine room?
You can't hear him. So what he's asking the temperature, the high temperature of a lithium battery. Like you said, you don't want to install them in an engine room. So he's wondering what's that? Is there a range?
Yes, you see the specs on. Always refer to the specs on the particular manufacturer, but it's typically nothing greater than 140 degrees Fahrenheit. Operating temperature. They can be stored over 170, and below. The low temperature regarding storage is minus 40 F. So that's the storage operation, but operation is basically freezing to 140 degrees.
Okay. Thank you. So now, we got another question.
Another lithium question. If you leave your batteries in the boat all winter, how do you keep them charged if you can't do it below 32?
Did you hear that?
Yes, I did. Great question. I'm faced with that every winter. Your BMS will not allow charging, obviously, and you can't. As soon as the BMS disconnects, the batteries are basically in a storage mode. So they have extremely low self-discharge rate, and they'll last a year. So the answer is you can't charge them unless you heat the compartment. And there's our batteries, and Victron has them as well. And there's a lot of popular brands that have internal heating, and that will allow charging. So that'll keep it above the 40 degrees, which is the favorable low temperature. So they are internally heated. You can also heat the compartment yourself. If you don't have a dedicated shore power system for keeping your system charged, you have to consider that as well, because the internal heating will use energy. So there's a finite time that it can heat itself. But if you have shore power, then it's infinite. But again, the BMS is key to when it does get too cold or it falls out of the parameters for operation, it must disconnect. And a disconnected battery that has energy in it will stay that way for months.
Okay. John.
Is it bad to keep them charging all the time?
No, it's not. When it comes to charging batteries, you should have a charger that has a proper and proven lithium algorithm. So your batteries, lithium batteries, don't charge like AGM batteries. They need to be charged at that bulk or absorption voltage, approximately in a 12-volt system, 14.4 plus or minus a couple tenths. They have to be charged until they're nearly full, where lead acid batteries, if they're anything above 13 volts, the smart charger will default to a float setting immediately. A lithium battery must be charged over 14 volts until they're 99% full. They'll take almost their full current. For instance, a 100 amp hour battery will take 100. It'll demand 100 amps until it's 99.9% full, and then the battery charger will then, based on its settings, and also an amp hour counter, we'll get into amp hour counting, but as soon as it falls below about 3% of its amp hour rating, as soon as the charge current falls below 3 to 4%, or 3 to 4 amps in a 100 amp hour battery, you'll meet the parameters of the amp hour counter and also the charger, and then it will drop to a float setting. A fully charged 12-volt battery, lithium battery, is about 13.3, where a lead acid battery, whether it be gel, AGM, or flooded, fully charged lead acid battery is 12.6. So there's quite a difference. So the answer to your question, you can almost all battery chargers will drop to a float level or maintenance levels around 13.5, 13.6.
Yep.
Can I just add to that? From my experience, Tom, I know we don't use batteries on charge, but as soon as it goes below 40, the BMS shuts off.
Right.
So then any parasitic electricity that's stealing from the battery takes it down, and you've got to check on them. If it's cold, I use heat blankets and a hair dryer, bring them back up to 40 degrees, so they start charging again. Okay. Or you can completely turn the system off, right, Chris?
I can't hear all that, Peter. I'm sorry.
He's not in here, yeah. Basically, what Chris was saying is he puts a heat blanket on the batteries, and the system he's just reiterating what you said, that the amp out, it'll automatically shut off if it gets below 40 degrees. But he'll use a hair dryer or a heat blanket to keep the batteries warm or warm the batteries up so they start charging.
Right, absolutely. It's the batteries are smart as far as they will shut off. They won't allow. Their job is to make sure that you don't have any issues. And if it's not warm enough, I'm sorry, they're going to shut off. They're going to do what they're told to do because they meet certain standards. There are safety standards, UL standards that most batteries meet. The Victron does have use UL cells, but the standards and safety standards are constantly changing and improving. ABYC has come out with is coming out with a standard related to venting lithium batteries. So that's going to be something that changes. And I'm not exactly sure why, but I know there are changes coming out. But the standards are constantly changing, and it's a very, very fluid situation when it comes to the standards.
All right, is there any more questions on lithium batteries? One here. Okay.
Do these need to be put into an area that gets full airflow?
Did you hear that question?
I heard about ventilation. Well, you should always want to be able to ventilate some of the heat that can build up. But lithium batteries, unless they're abused, won't get hot. That's for sure. But you always want to have ventilation just to keep them cool, so you don't have that situation. But it's not. I've installed systems that I'll have a thermostatically controlled fan just to keep them below 110, 120 degrees. So it's if you have a situation where you think it's going to get warm in there, by all means, ventilate it. But it's not necessary. You're not emitting explosive gases like a potentially like a lead acid battery or an AGM battery. So no, that's not the case. But if it's in a compartment near the inverters, naturally you're going to be ventilating that compartment.
Thank you.
Any more lithium questions?
And we can
All right,
always
Chris.
get back. We can get back to it if you think of it. We can get back to it. Now, regarding okay to move to AGMs.
Yes.
Okay, AGMs. The main difference and between an AGM battery and a flooded and gels fall under the same category regarding safety standards is they will not gas past the flammable point, and they also don't need servicing, or they don't allow servicing. You can actually, in most cases, mount an AGM battery on its side because they're not spilled, and you'll see that they typically say non-spillable batteries. So when it comes to my experience regarding AGM batteries, there is not a lot of advantage to performance, such as amp hours. There is no super flooded or I'm sorry, no super lead acid battery. Again, AGM gels and flooded batteries are all lead acid. The advantage is safety and the ability to install a lead acid battery in a living quarters. So they are designed not to gas past a flammable point. And again, there's no danger of spilling. There are strict charging parameters that you must pay attention to when it comes to AGM batteries, because you cannot replace the fluid, and that is temperature compensation. Every good charger will have that can be used in AGM batteries. Will have a temperature compensation probe, and that goes on the batteries, and typically goes on one of the posts, and that way you can gather the internal temperature, and then the charger will adjust the charging amplitude, voltage, accordingly. So in the summertime, you want to lower the voltage to again minimize any chance of gassing. I did say summer, right? Summer, you're going to lower the voltage, and winter, you're going to raise the voltage because the impedance of a lead acid battery is higher when the battery is cold. So you have to raise the voltage to overcome that internal impedance to charge your batteries fully. So those are the main differences between AGM and a flooded battery. You cannot put a flooded battery in a living quarters. Never, 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 never. By the way, Victron does make, again, lithium, and I've got some behind me. I've got some samples of AGM batteries, and their AGM batteries are extremely attractive price-wise. And if anybody's interested in that, I can certainly help. More questions on AGMs or gels?
Nope, I don't see any.
Okay. All right, let's move on On to amp hour counting and battery bank sizing. Every battery has an amp hour rating. Every deep cycle battery, I should say, has an amp hour rating, and let's touch real quickly on deep cycle batteries and start batteries. Start batteries have thinner plates to allow for high current in short bursts to turn over your alternator or turn over your engine, where house batteries have thicker plates and can sustain medium currents. They are not typically good starting batteries, although you have enough of them in parallel, you can start anything. But house battery or deep cycle batteries have the ability to provide medium currents in the 100, 200 amps, 300 amps for longer periods. And deep cycle batteries are designed optimally to provide 500 cycles, 600 cycles at 50% discharge. 50% discharge is, in a case of a 100 amp hour battery, it's 50 amps removed from the battery bank. And a shunt is the way to monitor those amps as they come and go out of the battery bank. Peter may have I believe Peter has the smart shunt. If you want to pass that around, just so you can relate to it. And I'll get back to the ratings of a deep cycle battery. Again, a deep cycle battery has an amp hour rating, typically stamped on it or on its label, and a group 27 battery, which is like a very common size, typically around 100 amp hours. So we'll stay with that number just for simplicity's sake. And the amp hour rules are based on it's what's called the 20-hour rule. And theoretically, a 100 amp hour battery will provide 5 amps for 20 hours. And that's how all the 20-hour rule is based. And this applies to lead acid batteries only. It does not apply to a lithium battery, although they are rated in amp hours, but their ability to perform and provide current is much greater than a lead acid battery. So once you exceed in an AGM battery or a lead acid battery, as soon as you exceed that 5 amps, your 20 amp or 20-hour rule goes out the window. No longer, if you draw 10 amps, you might say to yourself, well, I'll get 10 hours. That's not the case. The ability to provide the current falls off logarithmically. You will not be able to use that 20-hour rule as soon as you exceed that rating. Now, what do we do about that? We have, again, that shunt helps us calculate time remaining. It gives us the amount of cycles. It'll present that there's an app, and you can also have a meter that's attached to that, but it'll display depth of discharge, the amount of cycles you've done, average depth of cycles, very accurate voltmeter, very accurate ammeter. It also considers temperature and also has some programming in there related to some calculations that are used for lead acid battery life and time remaining, called Puchard's exponent. Puchard's exponent is an important calculation that is programmed into these smart shunts that will help adjust the time remaining. And it's based on chemistry. And the flooded battery and an AGM battery and a gel battery all have different ratings when it comes to the time remaining calculation. And these are all programmable in that shunt's in this case has a Bluetooth app. There's also other shunts that have remote displays that you can calculate and or program accordingly. So it's important that your shunt is programmed properly in order to to reach our objective and display the proper time remaining. So when it comes to sizing our battery bank, we have a certain amount of power available in a lithium AGM battery. Again, if we've got 1,200 watts, we've got, it's as simple as the math here, and a lot of this is based in that in our Wiring Unlimited book. You'll see on page 2 and 3, 3 and 4 actually. Ohm's law, Watt's law, and you can calculate the stored energy in a battery. If we have a 12-volt battery and it's 100 amp hours, you multiply 100 times 12, you have 1,200 watts. We have 1,200 watts of stored energy, of which, when it comes to designing with a lead acid battery bank, we only have 50% of that usable repeatedly. We talked about the cycling capability of a lead acid battery. We've got 500 cycles before that battery becomes all sulfated internally, and its ability to store that energy is basically depleted, and you have to get new batteries. So, but when it comes to a new battery bank, we've got 600 watts of repeated usable energy. So if we've got we want to run a 100-watt bulb, we'll get 6 hours out of that battery bank before it is 50% discharged. That doesn't mean you can't discharge it completely, but if you do discharge your battery bank completely, you'll get less cycles. So that's the downfall of lead acid. It doesn't perform well especially compared to lithium batteries. But that's where, again, designing a proper system, if we want to, if we're going to run a 100-watt bulb for 6 hours, that's not very much energy. We want to be able to run a fridge. We want to be able to run a microwave, sometimes an air conditioner. So and then sizing this battery bank properly goes a long way to having an enjoyable experience and not having any nuisance timeouts of your loads. And now there was some discussions that Peter touched on CPAP machines, running those off an inverter. And there's no escaping the math here. And you have to know there are 2 types of CPAP machines. I've never used one myself, but I understand that there's a CPAP with heat, and its load is much greater than a CPAP machine without heat. So you must know the specs of your device, and every device has a spec plate on it, and it may say amps and volts, or it may say watts. So, but you can, as soon as you determine that load and the time that it's on per hour, you can calculate your needed power system, the actual battery bank that you require. So it's not a difficult process, but if it's not done correctly, you can have a undersized battery bank, and that's certainly can be a nuisance. Now, when it comes to lithium batteries and their performance, again, you can discharge lithium batteries to conservatively 80% energy removed and get 3,000 cycles. When it comes to the cost in relation to lead acid batteries, the cost of lithium batteries is about a third over the life. If you're going to use 3,000 cycles, calculate the time that you use your boat. Is it safe to say most of us don't sail all year round, or don't boat all year round? It's Jersey here. We're lucky we get 4 or 5 months of continued usage. Show of hands, how many people keep their boat all year round in the water? And is that local?
I think you keep it in Connecticut in the water. Some are in Connecticut, some are in North Carolina.
Okay.
Yeah. So But there's not very many. There's what, 2 people here, I think.
Yeah. So yeah, my point is, for the most part, if you get a lithium battery bank, and it'll probably last you the better part of 10 years. Again, depending on the usage and the amount of cycles you get, and that's another advantage to the shunt that we're touching on, is you can record the amount of cycles, so it helps you determine the life of your battery bank, and also protect your warranty. A lot of these batteries have cycle warranties. A lot of batteries have life period warranties. You'll see lithium batteries companies that offer 10-year warranties. Victron is a 3-year warranty. But you'll see some out there that are 10-year warranties. But I also know some of these manufacturers have gone out of business that have offered these warranties. So you have to, it's buyer beware when it comes to that. Where the source that they come from, country of origin, and the reputation are things you have to consider, as with anything. Any questions on sizing battery banks?
I don't see any hands. Maybe as we go further, they'll start asking questions.
I understand.
Oh, actually,
Oh, okay.
how much battery do you need for a mini fridge?
Well, typically a mini fridge like that, only a dorm fridge you're referring to?
Yeah, maybe a little bit bigger, put around that size.
My experience is they don't draw more than 2 or 3 amps AC. So again, you're dealing with 120 volts, and I'm assuming you're dealing with a 120 volt refrigerator. So again, with the math, what we do in a case like that, it's 120 volts times, let's say, 3 amps. So you got 360 watts. Now, the refrigerator is not on all the time. Ideally, these things are designed so that their cycle time is about 50%. That means they're on about half the time. So we're not using 360 watts per hour, we're using 180 watts per hour. And that is an average. If it's extremely hot, or on days where the door's open all the time, of course it's going to be on more. So these are the variables when it comes to calculating something like this. So if we use the 50% rule, we're using 180 watts, and we want to run that thing off our battery bank for 12 hours. We do the math. 180 times 12 is 2,100 watts. So we want to. That's a lot of energy. So we just said that Group 27 battery has 600 watts of usable energy. So we need at least 3 batteries, 3.5 batteries, to run that refrigerator. 3.5 Group 27 batteries. So let's make sure we got our details right here. To run that refrigerator for 12 hours. That's without solar. And so we consider worst case when we calculate these things. That's without solar. That's without an alternator having run. That's overnight. So that's how you design these systems. Is the worst case scenario. That's without, it's for rainy days. If you don't have any production, we want to be able to run that refrigerator and keep our beer cold. And that's the main aspect and main consideration here. Is that clear?
Yes.
Yeah, it's when you consider the math side of this, and these are all knowns. There's no escaping this, and it all has to do no escaping the math here, and it all has to do with the ratings that we have access to. It's the data plate on your device or your load, and it's the amp hours on the battery. It's all relatively simple. It's a matter of getting the experience and the know-how. Designing the system properly goes a long way. And then we talked about just now the worst case scenario. Absolutely no charging source, no solar, no alternator. You can, of course, if you run your engine, if you've got a 100 amp alternator, that's 1,200 watts, and we're running that for 1 hour. And we've got one battery that's completely dead, one Group 27 100 amp hour battery. We're going to charge that battery fully in 1 hour, theoretically. That's not always the case. More likely the case with a lithium battery because they can absorb energy better than a lead acid battery. Lead acid batteries, the resistance becomes increasingly higher, the resistance and the ability to accept current, that is, as they get fuller. So it might take a little more than an hour to charge a lead acid battery, but that's where your amp hour counter comes in. It'll tell you exactly, it's counting the amps as they leave the battery and as they go back in, and not till the battery is completely full, all those amps go back into the battery, and you meet the parameters of the settings on the shunt, the smart shunt in this case, the battery will say 100%. So, and the same goes for solar. Solar and an alternator and a battery charger are all devices that will charge the battery. They all do the same thing. Of course, they have their limitations based on their design, the amount of solar that you have, but they're all doing the same thing. They're all 3-step chargers, and we'll get into 3-step chargers when we get into all those types of chargers. But we got into this because we are considering these other dynamic charging and or charging devices that will help extend the life of the battery and our capability to stay away from shore power. That's, not including chargers in that case, but solar and your alternator. Your alternator is a fantastic device, unless you've got a generator already. An alternator is a fantastic device to run things dynamically or prolong your stay on the hook and away from shore power. So there are lots of ways to again prolong how long you can stay and how long your battery bank will last. Okay,
We got a question.
So if you have a full-size stand-up refrigerator, basically double the numbers, and the second part of it is, do you run it on 12 volt or you better running it on the 110 through the inverter?
Well, a large refrigerator like that, DC, is likely very, very expensive, but naturally you'll have a little more loss when it comes to using an inverter. Minute, you can always, inverters are typically around 90% efficient or 10% loss. So if you look at the cost of a DC refrigerator versus the loss in energy, and it's certainly a complex calculation as to what's better in the long run, but you'll have a hard time finding a DC refrigerator that's full size. That's for sure. It's they were common. They are common in the RV industry, but regarding the math is the same as far as the considering the loads and the battery bank size that you need. But using off an inverter is minutely less efficient. I don't dare discourage or encourage going to a DC refrigerator because I understand they are extremely expensive. Go.
Yeah. Let's say, let's assume that I don't have solar right now. We've done the calculations. You spoke briefly about alternators. I mean, if you could say normal discharge running a small fridge on a boat, I mean, how often should you plan on, whether you think you need it or not, your generator on a given day just to keep your batteries charged up if that was your only option before you add solar? I mean, what is
Let me, it might be better to answer that, hold that question until we talk about solar.
Okay, definitely can do that. But this gentleman didn't have solar.
Okay.
Correct?
At present, I do not have solar. I've got solar in the past.
So the rule of there's several variables. How much room do you have for a battery bank? Number one, but also how big is your alternator? But typically, you end up running if you don't have solar or any other way of recharging your batteries. It's understood that again we're programmed or designing our system to last 24 hours. So you're going to be running your engine every morning. And I think Peter told me about experience yesterday. He and I were talking, and he told me about his experience. He had to run his generator an hour in the morning and an hour at night.
Half hour.
All right, so that would be,
but he's got that's a generator.
That wasn't because I had to, that's because I wanted to run the microwave, and the hot water heater and a toaster oven, right? So, you know.
those
We want to be at home. We want all the comforts of home.
You bring up a good point. Those are a microwave, a heater, a coffee pot. These are battery eaters. They really can shorten the life and take a lot of energy out. All those devices are over 1,000 watts. That means you're drawing over 100 amps out of the battery bank. So those are, and that you bring up a good point. It's wise to help extend the life of your batteries. If you have a big source like a generator, to use it during those heavy load periods. But to get back to the gentleman's question, it's typically when I design or deal with the cruising customers, and if you don't have a generator, and these smaller boats and the medium-sized boats, in the mid 30s to 40 feet, where a lot of them don't have generators, you've got no choice but to run your engine. And if you've got a 400 amp hour battery bank, which is medium-sized, and you discharge it 50%, so you're missing 200 amp hours now, and you've got a 100 amp alternator, you got to run your engine 2 hours. So that's but again, there's no escaping the math. But if you've got a larger battery bank, you got the advantage of putting a larger battery bank, but still you have a 100 amp alternator, you've got to run it longer. If you've got an 800 amp hour battery bank and you've used 400 amp hours, now you got to run it 4 hours. So it's and they do make larger alternators. You can get a 200 amp alternator. So now you've cut your charge time in half. So there's no escape in the math here. And having an amp hour counter is priceless. Not knowing voltage alone is never a way to judge the condition of a battery, especially a lead acid battery. And the reason for that is lead acid batteries, as they degrade, they naturally sulfate. So their amp hour rating is reduced. So a fully charged battery, lead acid battery, again, is 12.6. There's 6 cells. A lead acid cell is 2.1 volts. So a fully charged 12 volt battery is 12.6. If it's below that, you've got, and when I say it's below 12.6, if after you charge it and you let the battery rest and gravitate or settle down, and if it settles down below 12.6, obviously you've got a cell problem. And we see that after a couple of years, especially if the batteries aren't maintained properly. When it comes to maintaining lead acid batteries, you should consider desulfating them. Desulfating is a process of overcharging the batteries. When using a charger, there are electronic desulfators. These also help extend the life of the battery. The desulfating is also referred to as equalizing, and that's a matter of overcharging a battery. And the object there is to boil the battery. You overcharge it, and I'll get into the dangers of overcharging the battery. But you overcharge the battery, it agitates the battery, literally boils it, and knocks the sulfates off the plate. The sulfates fall to the bottom, and therefore you have cleaner plates, and the ability to transfer electrons is greater. Now, the downsides to equalizing and the dangers of equalizing, of course, are when you're overcharging a lead acid battery, it produces hydrogen, and that's extremely explosive. So every time you do this, you've got to have a very well ventilated area. And there's if you have flooded batteries, the advantage there is you can actually take the caps off, and you can observe the cells, and also do a specific gravity reading. Specific gravity is one of the best ways to judge the condition of a lead acid battery. That's a matter of using a hydrometer, and it's a good way to know exactly where you stand and to help maintain the life of battery. Flooded batteries are of course the least expensive type of lead acid battery, but again, they cannot go in the living quarters. You can't do a specific gravity test on a AGM or gel. Again, they're sealed. But There's one brand of AGM battery that I know you can equalize, and that is made by Lifeline, and they are becoming less popular because they're harder to get. But that's the only battery, because they have a patented valve design. But most other AGM batteries, that can't be equalized. Any questions regarding that?
Chris, if I can ask, when you're starting to size a system, when you're working with a customer, is there a sheet that you like to use, or that you would typically, give to your customer for consumption to fill out?
I heard most of that, but if you wouldn't mind helping me out.
Yeah, so the question was, do you have a sheet, like when you're sizing, when you have a customer and you're sizing up what size battery bank you would need, do you have a sheet that you give that customer that he can put down, with all of the stats, the refrigerator, the CPAP, everything, and label it out so you know how to size it?
I don't have one. There's the Xantrex has a design sheet on their website. I don't believe Victron does, but it's as simple as adding your main appliances and just adding up the watts. And then also you're going to have to, a lot of it is, dare I say, guessing, but it's because there's so many variables based on cycle time when it comes to loads and short-term usage, such as microwaves and coffee pots. But the advantage, so when it comes to designing a unit or designing a system, it can be difficult. You've got to err on the side of caution when it comes to considering your loads. I use 50% rule when it comes to refrigeration. When it comes to microwaves and coffee pots, you can use a 5% rule. So those are things. Everybody's different, but you have to use your experience. I use my experience based on those types of loads. So to answer your question, I don't have a sheet, but I can quickly print one or create one or certainly help you with the system design. But no, I don't have a sheet I can just print out to you. But Xantrex, again, Xantrex.com they're another manufacturer. Xantrex.com. They have a sheet there, and if I can find that, and I'll send it over to Peter, and he can forward it to all. But it is. I understand your concern. It's important to have all your information when sizing your battery bank.
Any more questions on that?
Hey, Pete, can I just bring something up?
Sure.
Just a reminder, we're talking about coffee pots and all the creature comforts. We have to remember to size for the chart plotter and the radar unit, especially for those of us that sail, because during sailing time, we're not generating any electricity, most of us. So we got to make sure that we're sizing the battery for the time that we're going to be using the chart plotter or the radar unit during the day while we're sailing, right?
Correct. Did you hear that?
Absolutely. Absolutely. We're and you bring an excellent point. I was thinking about that navigation and everything from your electronics, of course, your radar, your depth sounders, your lights. These are things that have to be considered. Now, how do you determine that? That's where a smart shunt. And these shunts are so inexpensive and so easy to install. If you're afraid that you've missed a load or something like that, especially parasitic loads, comes to water pumps, and we didn't talk about that. I'm sorry, bilge pumps, critical loads that we have to consider. That's where it's a smart shunt is very important and very, very helpful in determining your loads. You can install a smart shunt and let it sit there for a week, and you can see the history. It's so simple. You can see the history, your daily use. Your average cycle. It's a great tool, and it's easy. You can download an app on your phone right now from VictronEnergy.com. We can talk about that, and we can show you. If you go to your app store, I have an iPhone, but you go to your app store, go to Victron Energy, Victron Connect, and it's a great tool. And I can show you the app related to the smart shunt, and it's truly fantastic in the history that you can access on this. So my point there is, if you're very concerned about missing a load or not knowing exactly what you have, you can put this smart shunt on and look at a week later, look at your history, and you can get a much better idea as to what your loads are. Now, we don't always have that luxury when we're designing a brand new system, but and you don't have to replace your batteries to find this out either. You can use your present batteries, just install a shunt, and away you go. Now, you notice that shunt only had 2 terminals on it. Now, your battery bank, your house battery bank, you can bet it doesn't have just one negative wire on it. You've got an alternator, your whole DC system return. You've got your electrical panel return. You've got other little loads, whether it be your bilge pumps, and all coming to your negative of your battery bank. If you've got, hopefully you've got a well laid out system that has a bus bar. If that's the case, all you have to do is, when it comes to installing the shunt, you remove any negative returns that are coming to the battery bank. They go on the system side of the shunt, and you have to create or provide, and I can certainly do that, provide another cable that goes from the battery side of the shunt to the negative battery of the house battery bank. The idea of a shunt is a precision resistor. Excuse me. Is a precision resistor, and you'll notice on the side of any shunt, if that shunt's still there, you'll see the ratings on it. It's 500 amps and 50 millivolts. What that means is it is a linear device, and again, a very basic device applying where you can apply Ohm's law. As 500 amps flows through this thing, it produces 50 millivolts, and and again, linear. So if it's 100 amps flowing through it, there's 10 millivolts. So with that, it can calculate. It's got voltage because it's got a voltage sensing lead that goes on the battery positive. So it knows current exactly, and the other variable or constant is time. So it can calculate anything. It's got wattage. It looks at current going through, and then it can calculate based on its programming. It can calculate time remaining, and of course, it looks at as we discussed earlier, the average discharge, the average cycle, amount of cycles, deepest cycle, and it keeps all of that in its records. So it's an excellent tool for helping you determine your loads and determining your battery bank size. But without having, and I get into this quite often, without having a good charging source, you can, let's hypothetically say you're going to have a 10,000 watt hour battery bank, but if you can't charge it, it's only good for while you're away from the dock. It's good for while you're away. So you can, if you're using 2,000 or 3,000 watt hours a day, you're good for 3 days, and you got to get back and recharge. But that's where it gets into the ability to recharge the battery bank, whether it be a very powerful alternator, or lots of solar, or a generator, an inverter charger, or just a charger. So these are all things that have to be considered. Let's see. I'm going to take a drink of water. Forgive me. Any questions?
I don't see any.
I don't see any. Okay. Want to touch on solar?
Absolutely.
We can do that. Okay. A solar panel is basically made up of lots of solar cells that all have a voltage that they will produce based on their exposure to the sun, and the voltage they produce and power they produce is based on the size of those individual wafers, etc. And they are placed in series, and they produce, typically in a 12 volt panel, they'll produce an open circuit voltage of about 20 volts. What does this all mean? We can't use 20 volts to charge our system, so we have to have what's called a charge controller, solar charge controller, between the solar array and the battery bank. The sizing a solar system is, it's very important that we consider the proper charge controller, and also how, let me take a step back. Your surface area that you have available for laying out your system will also dictate how much power you can charge our system with. Again, designing the system, let's say hypothetically we've got room for 2 100-watt panels on our, and that's all we have room for. And I sent some prices and model numbers of flexible panels over to Peter, and I think he shared them with you. And there's several different sizes there. Xantrex makes a fantastic flexible solar panels. It is peel and stick. You can also put them and sew them into a Bimini or a Dodger cover. And but hypothetically, let's use 2 100-watt solar panels. So we have 200 watts, and sizing or choosing a charge controller, such as the one I sent to you, Peter. Using the 200 watts, if we have an open circuit voltage of about 20 volts, we can put those panels in series or parallel. The panels, when you put them in series, you get twice the voltage. You have 20 volts, you end up having 40 volts. What's the advantage to that? The advantage to putting them in series is you get less voltage drop, especially over longer distances between the array and the charge controller. We want to have the charge controller closer to the battery banks, again, to eliminate and or decrease the potential for voltage drop. The disadvantage to a series installed solar system is potential shading. One of the issues we all know about is, and we're all talking about sailboats here for the most part. 90% of us or more in all sailboats.
No, it's 50-50, 50% sailboat, 50% powerboat.
Okay. The disadvantage of solar on a sailboat is that stick they got in the middle there, causing shading in the boom. And I'm kidding. I grew up sailing. So you have shading to consider. We want to mount these panels where you're going to get the minimum shading. When it's on the hard top of a power boat, we want to be away from the radar or any antennas. Minimize the shading all you can. But that, again, we were discussing series installations of solar panels. Series, if you have one of the panels is shaded, if there's not any bypass diodes in the panels, and these panels have bypass diodes, but with less expensive solar panels, you'll have decreased production even less than one of the panels. So I personally try to put the panels in parallel when we can to minimize any potential problems related to voltage drops and or production issues related again to a series system. So every charge controller, you notice that charge controller that Peter's has passed around there, you'll see the 2 numbers on it. There's in this case, it's a 75 and a 15. I believe that's the one I sent. The first number has to do with the maximum voltage that you can apply to that coming from the solar. So it can take 75 volts max. That means we can put 3 of the panels that I was talking about. If I had, again, these are hypothetical and made up panels. So we had open circuit of 20 volts. 3 of those in series would be 60 volts. So we are well within the parameters of that charge controller. We can't hurt the charge controller. If you put a greater voltage than the rating of the charge controller, you will damage the charge controller and your warranty is over. So when it comes to considering the system design, you must consider open circuit voltage. All these numbers are on the the sticker and the nameplate of the solar panel or the gated data sheet. Go to xantrex.com. Those numbers that I provided to you for those panels that I can provide for you. All the spec sheets are at xantrex.com, or any good manufacturer. You'll be able to find the spec sheets, and you'll see on those. You'll see open circuit voltage. It's OC V, open circuit V, and you'll see peak. And it's going to be the highest voltage number you see on there, but that is what we must consider, because when the charge controller shuts off, and it will shut off because when the batteries are full, the charge controller's job is to charge the batteries, but also protect the batteries and not overcharge them. And we'll get further into that. I lost my train of thought. We must consider again that open circuit voltage. Otherwise, we'll damage that charge controller. The charge controllers, their job is to, of course, charge the battery, provide the energy that we're missing out of the battery bank. And the charge controller is fully programmable for any chemistry. These charge controllers are. Not all charge controllers are. You have to look at the spec sheet, make sure it is. If you have lithium, make sure that you have the option of lithium. But of course, there's an AGM algorithm and flooded algorithm, and you can change all those parameters. All these charge controllers have Bluetooth. There are some that don't. But I highly recommend you get the Bluetooth charge controller, because you can use the app on your phone to set it up. You will have to adjust it for the battery type and chemistry that you have in order to charge them properly. Now, regarding your installation, you've always on the subject of safety, we always put overcurrent protection with every circuit when the solar panel wiring is going, when it comes to the input to the charge controller, because you'll see on the terminals on that charge controller, it's got PV, it's got battery, and that particular one has a load, I think, output. We can discuss that. But every circuit, on the subject of safety, every circuit must have overcurrent protection, according with ABYC and UL, National Electrical Code. There's no escaping any of this when it comes to your system design. If in doubt, there are also some great apps. I recommend you. Let me get the name of a very, very good app when it comes to designing your overcurrent protection and your wire size based on drop. Let's see that. Forgive me. I'll have to get back to that. I apologize. But for instance, you would have a circuit breaker for your solar array. The standard for wiring related to solar panels, the standard you'll see, there's number 10 wire. Number 10 wire is rated for 30 amps. That is per the National Electrical Code. And so you want to prevent a fire, you want to have a 30 amp breaker, 30 amp fuse between the solar panels and the charge controller. The output of the charge controller, for a 15 amp max output, we want to have a number 12 wire, which is rated for 20 amps, and therefore we would have a 20 amp breaker or a fuse on the output. There's again, there are lots of apps online and or sources that you can find the proper overcurrent protection for any of your circuits. But again, it's critical that you do protect for overheating and the fire. Now, for larger arrays, of course, you can need a larger charge controller, and you can they are available in any size, and of course, greater input voltages. If you happen to have a larger 24-volt system, or if you decide to have high voltage array, in other words, have several panels in series, you can get charge controllers that can accept up to 250 volts on their input and a maximum of 100 amps out. So there's many different products to choose from. Again, when it comes to designing your system, having the least amount of shade will lead to maximum production. Solar panels will have reduced production based on angle. Of course, this time of year, and we're closer to winter, the sun angle approaches about 25 degrees. And you'll have very poor production unless you've got a tilted solar panel that can face the sun. So these are things that you have to consider. I don't expect anybody to have tilting panels on a boat, but you must understand that you will have maximum production between about 10 a.m. and 2 p.m. and production will fall off. So these are, again, things that you must consider. I know we're touching on this subject very quickly. Do you have any questions?
Can you explain the bypass diodes that you were talking about in the solar panels when they're in series?
Explain bypass panels. Is that the question?
Yeah.
Bypass diodes. Well, again, it basically will bypass the whole panel when it's related to the current that's flowing, because when you have panels in series, the system current on the PV side and the photovoltaic side, solar panel side, is series. So if you've got higher resistance because you've got lower shade or higher shade on that panel, you're naturally going to have a voltage drop. So these bypass diodes will bypass that shaded panel to maximize the current flow. So that's their job. If you don't have the bypass diodes, you'll naturally again have higher resistance and therefore lower current flow.
Okay.
Can I?
Yep.
So if I understand that, the bypass diode, instead of shutting the entire panel down, it'll shut down a section of the panel, but let the rest of the panel operate.
Basically, the other panels.
Yes.
Yep. We got a question over here.
Yeah, it's flexible versus not flexible. Is there pros and cons?
Flexible versus non-flexible. What was the last part of the question?
Yeah, it's pros and cons.
Oh, cost.
Cost.
It's you'll see those panels. I think some of the panels I quoted are $370 for 110 watts. You can get a rigid panel for it's usually you'll see them for $1 a watt less. Right now you're looking at $3.70 for a flexible panel versus less than $1 a watt. So there's not a great production advantage. It might be 10% as far as area goes, but there's not a great advantage to flexible panels. The ability to, they're very low profile. Number one, again, they're peel and stick. You're not going to be drilling holes for the most part. You're not going to put a rigid panel on a Dodger unless you've got the brackets, of course. So you're not going to attach it to your panel or to your canvas. So there's obvious advantages regarding installation, but the cost is a major difference.
We have a question over here.
Is there a cost factor to be able to have them where you can actually walk on them if needed?
Oh, well, I don't recommend you walk on any panel. There's some of the you'll see some of the manufacturers, they'll tout you can walk on them. I don't recommend you walk on them. They can't take it. You might be able to, you might kneel on them, of course. It's not like where if you kneel on a glass panel, you might shatter it. It's a lot more likely, and you can kneel on the flexible panels, of course, but don't dance on them. Don't step on them. Don't brag about being able to walk on them. They won't last. You'll be bending those substrates and they'll break. I've had customers that they were sold panels with the understanding they could walk on them. In this case, it was on the gentleman's van or RV, and he was a photographer. He would set up his stands up there and do his photography. He was doing wildlife, and they lasted about a year, and they were just abused. And when I was talking to the Xantrex people, and they were touting, yeah, you can walk on them. And I said, is it in your literature? Oh, no, they won't put it in their literature. And there's a good reason for it. They can't take all that abuse. But again, leaning on them, and of course you crawl across them. But if you abuse them and walk on them consistently, they're not going to last.
Chris, we had another question. Tony, do you have a question?
No, that was my question.
Okay.
Walk on.
All right, Chris, you have a question?
Life expectancy panels on.
So the question is, what's the life expectancy of the Xantrex panels that you have or any panel? What's the life expectancy?
I haven't had any installed for more than 10 years. My experience has been is quite often these flexible panels discolor over time, especially after 10, 15 years. I've seen them discolor, but these haven't been around that long. Not that I've had experience with. So I don't dare say that they're not going to last 25 years like a glass panel, which I have plenty of customers who've used those glass panels for more than 25 years. Yeah, they'll degrade as well. But my experience has been that flexible panels will naturally become more opaque as they get older. I can't say it's the case here, but I haven't seen any yet that haven't degraded over time. Discoloring, becoming gray. So I avoided the answer to that question because I don't have the experience, and nobody does, as far as these Xantrex panels go. And the ones that I have seen that have been around longer than that have definitely discolored and become their production has fallen off more than 50%. So I would say 10 years, and then after that it's unknown. Yes, sir.
So in my application, I would potentially have to put the soft panels on top of a soft top on my flybridge, which means I don't have access to clean them or do anything else. So between the airport and bird droppings, they're going to get dirty, which is going to limit power right there.
Oh, absolutely. Absolutely. Any coveraging and dirt, that doesn't mean you can't hose them off. Naturally, if it's covered, it won't produce as much. No escaping that. That's for sure.
More questions on that? Oh, got a couple here. Done.
Average size of panels for the hard panels. Is there an average size? They all like 2 by 4 feet, 2 by 8 feet?
Oh, average side of flexible panels or any panels?
Hard panels.
It depends on the wattage, of course. Average in a 12-volt circuit, you usually don't see them over 200 watts. So it's 200 watts. Rigid panels are becoming more and more popular, and they're typically around 2.5 feet by 5 feet.
Okay.
For mounting the flexible panels, on a canvas, I've seen some bolt kits and stuff like that. Is that really the recommended way to attach them to canvas?
Oh, well, I haven't seen that. I know there's some panels that have eye points, grommets rather, but it defeats the whole purpose of having a canvas. You'll see Xantrex. Go to Xantrex.com, and you'll see a couple of videos right on their solar page where these are peel and stick panels, so they can literally hear. Now, Peter, you did this, didn't you?
I did. Well, I didn't sew mine in. Mine stuck to the hardtop, and I'll talk about that when we're done.
Yeah. So on the Dodger, I actually had a customer who had he had his canvas manufacturer come down, and he sewed corner pockets. Actually, no, that's the all enveloping zipper all the way around his panel, and also had an adhesive as well. But go to Xantrex.com, And you'll see an example. These people actually sewed corner pockets to hold the panel in place. But again, they had the adhesive. They actually had their Dodger on the floor, and they used the adhesive. They adhered it to the Dodger canvas, and then they also sewed corner pockets to contain it further. So that's an example. I don't dare say that's perfect, but that's an example of what some customers have done. And another customer, again, that I had recently actually sewed an all-encompassing. He didn't have an adhesive, but they had corner grommets that they sewed to the top of, not through the canvas, but to the pockets that they had in the corners, and adhered it that way too. So there's you can get creative in doing that, but it's certainly nothing. There's no need to reinvent the wheel, I think. But you're going to need a good canvas maker to incorporate that.
Okay. Do the panels themselves produce any heat?
Did you hear that? Do the panels produce any heat? Was the question.
They'll get warm underneath. That's a good question. That's a really good question. Yeah, and panels don't produce as much when they get hot. So solar panels, all solar panels will produce their maximum power when they're cool, and especially when they're cold. So the advantage. So this is a good question and a good subject. A rigid panel that is mounted a couple inches off the surface will keep itself cooler. A panel that is glued to a surface and the heat can't escape won't be quite as efficient. So I've never seen panels get hot to where they discolor a surface or anything like that, but they naturally can't keep themselves as cool.
What is your experience with bifacial panels?
Oh, good question. We installed some recently, and as long as they're exposed to a great source of light from underneath. If they're mounted very close to a surface, of course, and they're not exposed very well, you're not going to get much production out of them. But the customer I had a very large davit off the stern of the sailboat, and they were exposed to a lot of light off the water. So and I understand his experience has been very, very good.
Is there a recommended clearance? Like, say you're going hard panel, is there like a recommended clearance to keep them cool? An inch, 2 inches?
Oh, an inch is fine.
Okay. I mean, where's
you have airflow under there. That's the key.
So anything that's a soft panel is just going to be that less efficient if it's directly against your canvas.
Right. I recommend you look at the specifications. They'll talk about that. They'll address that as far as heat goes. And there's a production, typically a production range, efficiency range that they'll share with you based on temperature.
Bernie.
Can you mount the hard panels on the soft top bimini, or do you need a much stronger structure?
Oh, much stronger. You need to be. They have to be above the bimini. You don't want them resting on the bimini. They'll eventually wear through it, etc. So I've seen customers, depending on the brackets and the arch and how strong it is, they put brackets on either end, and you have to create a structure to support that. So you don't want a rigid panel on a bimini.
What is your experience and recommendation on higher voltage rather than 12 volt, maybe 36 or 48?
Yeah, forgive me, I didn't hear all that. And I can't. The sun is right behind you, so I can barely see who he is.
But the question is, what's higher voltage panels versus 20 volts? I can tell you that the big panel that he has that you'll see on the spreadsheet is the same panel that I have, and it's 39 volts. And how about storage? The batteries themselves.
He's talking batteries.
36 volt to 48 volt. 12 volt or 24 volt. That's his recommendation. Yeah, no, because then you're getting into all kinds of adapting down. You got different wiring. Right, correct.
You have to forgive me, I didn't hear all that.
Yeah, no, he was just asking about different storage voltage, like should 12 volt, 24 volt, 36 volt in the boat.
Yeah,
That.
you can certainly do that. I have lots of customers that go with 24-volt inverter systems. The advantage there is smaller cabling, a little more efficient when it comes to high current. Inverters, again, with large loads, draw a tremendous amount of current. For instance, a 2,500 watt inverter will draw over 200 amps. The potential for voltage drop over that system is greater, especially if you're not close to the batteries. Naturally, Ohm's law will dictate that will, based on your cable size, you'll have a voltage drop. But having a 24-volt system, and then you say to yourself, well, how am I going to charge them? I've got a 12-volt alternator. So we make, and there are a lot of manufacturers that make DC to DC converters. DC to DC converters will take, you connect the input to your 12-volt, your start battery, which is connected directly to your alternator. And its output can be for a 24-volt system. And there are lots of applications where that is completely necessary. And we didn't touch on the need for protecting your alternator when it comes to lithium batteries. And that's where DC to DC converters come in again. You've got to, the charging a lithium battery is very, very harsh on an alternator. The demand for current, due to the low impedance of a lithium battery, demand for current is very, very high, and you can overheat your alternator and damage it. So you must protect your alternator. That's something we didn't discuss at all. We haven't touched on the alternators when it comes to designing with a lithium system. So it's not unheard of to have a 24-volt system on a 12-volt boat. And you would have, of course, a proper charge controller if you had a solar system. So one thing we didn't touch on is when you're designing your system, your open circuit voltage, your MPPT voltage, maximum power point tracking, and that's what all these charge controllers are. Your MPPT voltage must be 5 volts greater than your system voltage. So if you have a 12-volt system which charges at 14.3 when it comes to a lithium or an AGM battery, your circuit, your PV voltage must be around 19. So it's really important that you size and design your system appropriately. And again, you can see all these numbers at MPPT voltage, which I mentioned is on your data sheet, your data plate for your your solar panel. Now, open circuit voltage versus MPPT voltage are two different things. The MPPT voltage is what the solar panel is rated at. It's important to understand. So I just said the MPPT voltage is around 19 volts. Well, still, I can't use 19 volts on my batteries. And again, that's where the charge controller's job comes in, is to regulate the solar panel's voltage as far as loading it, because a solar panel is not a regulated power supply. It is an unregulated power supply. It's extremely crude, and based on the loads, it will produce a certain voltage. So the maximum power point tracking name and or design of a charge controller, that's its job, is to regulate while charging the batteries, but keep the voltage of the solar panel at this MPPT voltage. And that's the only way you're going to get 100 watts. And again, in a panel that's rated 100 watts, it's the only way you're going to get your 100 watts out of that panel. In the old style type of charge controllers, which were called pulse width modulated type, they were very, very crude, and they didn't always regulate that voltage, and therefore you wouldn't get your 100 watts out of the panel. So they got really smart, and they designed these MPPT type charge controllers to regulate the voltage of the solar panel while charging its maximum output capability. So it's a balancing act. So what's the other variable we have is the shade and the exposure to the sun. So you got clouds going in and out, and the charge controller is trying to regulate that voltage and produce the maximum current. You'll see this change and you'll see the current going up and down. And the charge controller is doing its absolute best to get the most out of that solar panel. So there's a lot to understand what else is going on. And then again, forgive me, we didn't touch on the MPPT terminology there, but that's important. And don't consider a PWM type, and they're really not made anymore. But you'll see any good charge controller will have that terminology.
Chris, you got a question, Dan?
Yeah, I see on your tables, over 20 amps, the MVP controllers don't have the load terminals. Is there a reason for that?
They don't have which terminals?
The load.
The load terminal.
Oh, yeah, they're not as common. These are usually used for street lights and or nighttime loads, whether it be cameras and things like that. And what it does is, and I'm getting past your question, but they're not as common, so the demand for them is not as great. So there's it's a production and or a marketing issue, really, is what the applications are for. I sell tons of those things to customers in New York City doing remote cameras, and their job is to protect the battery and not over discharge it during dark periods. So they're powering a camera, etc., and they're completely off grid. So they use that. They charge the battery during the day, and at night they'll control the load, but make sure that the battery's not over discharged. But that's the main reason is just to applications, and you can probably find one by other manufacturers that have that. But otherwise, you would use what's called a battery protect solenoid, or another device that will shut off when the battery reaches a certain point.
All right, thanks.
Done.
What kind of transfer switches are needed if you're between your generator, your shore power? I'm sure you're gonna have another transfer switch just to run the solar system. Is that correct?
No, it's unrelated. Your solar system is going directly to your batteries. So the shore power would be fed to a battery charger that's also charging the batteries. But they're parallel loads and or charging systems. So they're when it comes to shore power, and we haven't touched on inverter chargers yet. That's a good segue there, but shore power, regarding transfer switches, inverter chargers have built-in transfer switches. Peter has just replaced his inverter charger. He had his Xantrex, now he has a Victron. But an inverter charger, depending on how it's installed, quite often on sailboats, they'll be installed between the shore power and your electrical panel and or your generator. And there's sometimes a slide out lockout switch that'll choose the source and how it feeds the inverter. But inverter chargers have a transfer switch in them, and that transfer switch's job is to determine how we're going to feed the distribution panel. If there's no shore power, an inverter charger will take the battery energy, invert it, or slice it up, make a square wave, and feed it to a transformer internally, and then step it up and feed your electrical panel with 120 volts. When the inverter charger senses that it has another source, whether it be a generator or shore power, it qualifies that shore power, both voltage and frequency, and says, okay, we approve this source, and we're gonna pass it through. The transfer switch then chooses the shore power, passes it through to the loads, and then it becomes a charger, and then maintains the batteries. So that's where a transfer switch, an internal transfer switch, can come from. But also on most sailboats, you'll see this slide out lockout switch, or a rotary switch that you can manually choose your source on how to feed your electrical panel. So there's several ways to do that, and depending on the size of the boat, will determine how that's done. Sometimes you'll have an inverter charger that will only feed a sub panel on a large boat. In other words, it only feeds the galley, choice outlets, and entertainment, etc. And you won't have it feed air conditioning. Air conditioning is a huge load, or a water heater. Again, another large load. You can have alternative ways to heat your water, of course, whether it be your engine or only when you have your generator running. So there's lots of variables here quite often it is the case that an inverter will only supply a sub panel.
Chris?
What's the solar panel output efficiency for calculating size? About 80%.
So the question is, what's the solar panel output efficiency for size?
If you got 100 watts, it's not gonna give you 100 watts, it's gonna be like 80 watts, correct?
Oh no! Oh, it'll put out 100 watts.
Huh?
Oh sure. But again, the variables there are temperature and exposure.
Yeah.
Oh, you get, if you have a nice cool day, you'll put more than the rating out by several percentage. I've seen 105% production out of a solar panel. So it's not limited to its rating not all the time. Again, it's less the rule, more an exception, but I've seen that. You'll approach rated output and designed output often. Any other questions?
Any more questions?
Want to talk about inverter chargers?
Sure. Yeah.
Okay. There are a couple types of inverter chargers: modified sine wave and true sine wave. Modified sine wave is becoming almost obsolete. The difference there is the harmonic distortion and waveform, of course, and regulation and sensitivity, load sensitivity. Modified sine wave can't run a bread maker, can't run a laser printer, although you probably won't have one of those laser printer on your boat. But bread makers, a lot of cruising sailors would have bread makers. The problem with the modified sine wave is when it comes to instrumentation and clocks, clocks will run faster, and therefore your bread comes out a little gooey. So if you have a bread maker, need a true sine wave. But again, the cost of sine wave inverters has fallen tremendously, especially with Victron. There's really no sense in considering a modified sine wave. There are more different types of, there's high frequency switching type inverters, which are lighter, but they don't quite often have the surge capability of a low frequency inverter charger, which is called a transformer coupling. They're considerably heavier, but they have great surge capability. Victron produces, for the most part, and the higher output inverters produces low frequency switching, transformer based inverter chargers, which again have great surge capability. The 3000 VA has a 6000 VA surge capability. On the subject of loading, and you heard the term VA. VA has to do with inductive loading. A 3000 VA inverter is truly rated at about 2,500 watts continuous. Wattage versus VA. Wattage is a resistive term. In other words, a water heater, if you ran a water heater, you could only run up to a 2,500 watt water heater, where if you run an air conditioner, you can run a 3000 VA air conditioner. It has to do with phase relationship between current and voltage. But it's important rather you consider the details when it comes to picking out an inverter and its ratings. You'll notice that Xantrex and other brands such as Magnum Energy rate their inverters in watts, where Victron rates theirs in VA, volt amps. And I don't like that they do that. It's a little bit misleading. Again, it says 3000, and you'll say, I want a 3000 watt inverter. It's not watts, it's VA. And I have to reiterate that and remind people that it's important to consider that. If you're running a hair dryer and you want to run a toaster, chances are you're going to get an overload light. on a Victron inverter, we might not get it on a Xantrex. Now, how often do you do that? And also, we're living on a sailboat. We, for the most part, and/or any other applications, any other mobile application, whether it be an RV or emergency vehicle. You'll get an overload light, and it's not often that you're running your hair dryer and your coffee pot at the same time. And if you do, you'll get an overload light. The unit might trip and turn off, and you'll say, "Hey, we're running power go." You look at the remote control, it says, "Oh, overload," and oh yeah, I shouldn't be running those things at the same time. Or you get a larger inverter, or you can put two inverters in parallel. So there's lots of ways to overcome that as well, depending on that usually depends on your room that you have available and the money you want to spend. Now, again, we talked about installation related to shore power, and a lot of smaller boats in the 30 to 40 foot range. Quite often, we put these inverters in series with the shore power. It makes your installation a lot easier instead of having to find a place for a sub panel, or actually dividing your electrical panel, which I've done before, which is not difficult, but it takes a bit of understanding. Dividing your electrical panel into a main panel and a solar panel, and have the inverter feed the the main panel and a sub panel, and having the inverter feed the sub panel, and you'd have those choice circuits on that panel, on that sub panel. And but having the inverter in series and feeding everything, especially if you don't have air conditioning, it's a lot easier. Literally, you're interrupting the shore power harness or cable. It feeds you have the shore power fed directly to the inverter input. The output of the inverter feeds your main panel, and away you go. When you're not connected to shore power, the inverter will feed the main panel, and you'll have power. It acts like a UPS. Everyone, or a lot of people, have a UPS for your computer at home, or you might have one in your house itself, and it'll choose automatically to power that panel. Therefore, keeping your fridge and your critical loads on all the time. The problem with that is your battery bank size. Excuse me. Your battery bank size, that'll determine how long you can do that. You can also choose the inverter. If you don't have any critical loads, you can have an inverter in a standby mode, where it'll sense when the loads are on. When it'll put a lower waveform or a smaller waveform out that produces or uses much less power, and therefore conserving battery. And when it senses a load comes on, and when the load comes on, the output will increase. And the inverter says, "Oh, we must have a load on, and we're going to come on, and we're going to power our light that came on, or some other load, the fridge that came on." So there's lots of options to help you conserve your battery life, because an inverter, as we said earlier, is about 90% efficient. So just to make its waveform, it draws about 30 watts. And that's about, 2.5, 3 amps out of your batteries, 12 volt bank, that is. And what a waste of energy. So 30 watts times 24 hours, that's a lot of energy. That's just wasted. The inverter is just making its waveform, and nobody's using it. So you can use a standby mode that will decrease that by, I think it falls about 3 or 4 watts instead of 30 watts. Or you just turn the inverter off. And this is where your amp hour counter, your smart shunt, comes into play again. When you can look at your smart shunt and see if any parasitic loads are on at the time, and you can actually see what that inverter is using in its production with its output with no load on it. So that's another great tool for the smart shunt to look at your parasitic loads. Now, your inverter charger, when used with, again, lithium batteries, they can be programmed for that lithium chemistry, as well as whether it be AGM. And you can also remotely monitor your inverters or your power system via a servo. A servo is a hub that talks to all your Victron devices, and it's displayed on a touch screen. Now, regarding your DC side of your inverter, critical that you have an inverter charger mounted very, very close to a battery bank, certainly within 10 feet. I prefer less than 5 feet. For a 3 kVA inverter charger, I recommend nothing less than 2-aught cable. That's 2/0 gauge. Don't confuse it with 2 gauge. And anything longer than 5 feet away, go to 4-aught. These are very, very thick cables, greater than an inch in diameter. And when it comes to installing your battery cables, make sure you have a good crimper. Make sure you're using tin copper battery cable, and make sure that you have proper overcurrent protection on those battery cables. So using a mega fuse or a class T fuse, but it's important that you have overcurrent protection on that DC side, as well as, of course, your input and output side. Regarding the overcurrent protection on the input side of the AC circuit coming from shore power, if you are more than 10 feet away from your shore power inlet, you must have another breaker installed. That's per ABYC. And if you're closer than 10, you don't need to rely. You fall back on the breaker that feeds your boat from your power post, etc. Relating to shore power, and when you install, if you don't have a galvanic isolator, and when you're installing an inverter charger, I highly recommend you install a galvanic isolator. The galvanic isolator installs on the ground wire between the shore power inlet and, in this case, the inverter. And if you don't have a galvanic isolator, even if you don't put an inverter in, you should seriously consider it. Certainly helps protect your vessel's fitting through hole fittings, and also, of course, your prop and shaft and rudder, anything metal. How many people do they know of have a galvanic isolator on their boat?
Couple.
Yeah, you should certainly, if you find that you're having galvanic issues, certainly consider it. It's very, very easy to install. That's addressed in the back of the book, in the back of the Wiring Unlimited book. They talk about galvanic isolators. Any questions related to inverters? I'm sure there should be.
Got a question on fusing.
He's got a question on fusing. Go ahead.
Do you recommend fusing on the start battery as well?
Oh, no, it's not necessary for ABYC either. The last thing you want to do is the cranking amperage on an engine starter can be very, very high, especially in the winter. So it's not necessary and not recommended. That's the only case, absolutely only case that ABYC does not insist on overcurrent protection. Your wire's got to be should be pretty large depending on your engine and your starter current demands. But a starter it's a very short-term load. So the answer is no.
Any other questions? Yep.
Sure. My boat has 7 batteries, God knows why. But
House batteries?
It has 7 batteries, and it has one charger, a Xantrax charger with a little controller. And I found one button on it that gives you amp hours, like it's kind of like a deficit. That I use it like a fuel gauge, and when it's charged up, it's kind of like near zero, and it goes negative after you use the batteries for a while, and then you got to charge it back up. How far negative should I go before I really have to charge it?
So I think I'm familiar with what you're speaking of. Some of these amp hour counters will they'll say 0, and then they'll discharge some, as you say, the negative side. Does it give a percentage, or does it just give amp hours?
No, it's amp hours deficit.
Oh, okay. Well, we need to know the size of your battery bank then. Do you know the group size?
I have no idea.
How physically how big are they? Are they 12 inches by 6 by like 9 or?
I'm sorry?
You have the dimensions of these batteries?
Dimensions, not like, are they,
They're all different. There's 6 volts and there's 12-volt ones. I don't know. It's just a shitload of data.
That's not helpful.
I don't know anything about
But you know what? You've got my email, and Peter, feel
Chris,
free.
Chris, I'm gonna, when we're done here, we'll give out your phone number.
Don't hesitate. Well, that's a good point. Give out my cell number. Pete, you got my cell number. Give it out, and if you want to send me pictures of something like that, and please, while we get to know each other, please include your name with your text if you send it to me, and send a picture. The picture is very, very helpful, and I can certainly help determine. It's not a good idea to have different batteries in the same battery bank. It's not a good idea to have different sizes, whether it be 6 volts and 12 volts in parallel. You're not likely going to have a fire or anything like that, but some of the batteries will end up being a load, a constant load, and it'd be a deficit to the system. So it's that's certainly uncommon and not recommended. Yes.
Yeah.
I have a lead acid battery question. Let's say
Go
I
ahead.
have lead acid batteries that all of them are good, but one goes bad. Everybody says if you change one, you got to change them all. I mean,
The same rule applies. Quite often, it depends on the age of the batteries. It depends on the usage that you expose these batteries to. So it's absolutely true. A new battery, when grouped with the year-old batteries, those year-old batteries they're well, for lack of a better term, they're not new anymore. They have had been sulfated. If you hadn't been equalizing those batteries, they are not as good as that new one. So what happens in that case? That new battery is going to do a lot more of the work until it becomes equal to the old batteries. And but it's not completely necessary that you replace them all, but it is recommended. But it all depends on the condition of the other batteries. And are these flooded batteries?
Flooded, yes. And I do have the supercharger or the desulfation battery charger type of thing.
So do a specific gravity test on them.
Okay.
Do a specific gravity test. If they're in excellent condition, by all means, but it all has to do with the condition of those batteries. So you naturally have a number one, if you're going to replace, if we determine that these other batteries, the old batteries are good and excellent condition, I don't have any problem with it, but naturally you have a different impedance with the age of the battery. As the battery gets older, it may have a greater resistance or depending on the manufacturer, a less resistance. So it falls back on Ohm's law. If they're going to perform differently, and one will become a load and the other is a greater supply, and you're just going to that newer one's going to do a lot of the work until it becomes equal with the others. But so you're not going to cause a fire, but you're not going to get the performance that you would hope to get.
Thank you.
John.
Do you have a recommended mega fuse that would mount directly on the lithium battery terminal?
That's a great question. Hang on a second. I got something for you.
You're tricky.
Send it up.
John will take one. I see your sales coming here, Chris.
Fresh into the store a couple days ago. I've got a friend of mine who's promoting his specially designed product. It's actually, no, this is not. Is it a fuse? It is a fuse. So this mounts right on a lithium battery. And this is is it a mega fuse? It looks like a mega fuse. You want a class T only?
What do you say?
You want a class T?
I don't know what I need.
This looks like a mega fuse.
Well, John, if you don't know, none of us know.
So this is an assembly. This has a fuse that is meant to be mounted right on top of the battery. This got a bridge. You actually have a disconnect. This meets ABYC. You've got a fuse. You got a disconnect close to the source, which is a strict ABYC recommendation. And there's a fuse holder on top of here. But this mounts right on a battery. And you've got a disconnect and you got the overcurrent protection built in. But I don't believe this is a class T. This is a mega fuse. So if class T, I don't have an answer for that. You might want to see, it's probably best to go to Blue C or someone similar like that if you need a class T. But this is a very, very good design that a friend of mine is promoting. But I can send you a better picture of that. What type of batteries do you have? What brand?
I bought Lifetime batteries.
I'm familiar with them.
Oh.
I didn't hear that.
We're all concerned with your look.
With my look? Oh, they're very inexpensive batteries. And I have a lot of customers that use them and successfully. I haven't heard of any bad experiences. I have never used them myself, and I don't have a good reason not to. I don't sell them because I don't have a channel to get them at a discount. So it's they are. I don't have anything bad to say about them. They're suspect because they're so inexpensive, but that's my cynicism and naturally born cynicism when it comes to cheap stuff like that, but cheaper stuff like that. But again, now we get into I'm going to touch on the safety aspect of lithium batteries. And we didn't talk about this at all. And I promised I would, and I forgot, to be honest. When it comes to considering lithium batteries, you should consider consulting. If you've got insurance on your boat, I'm sure your marina insists you have insurance. You better ask your insurance company if they'll approve lithium batteries on your boat. There are safety standards that have to be met. When it comes to their consideration, there's UL standards, there's ABYC that they consider. Do your batteries meet any UL standards? It's really important you consider that. Last thing you want to do is spend thousands of dollars putting lithium batteries out and find out your insurance company is not going to cover you. This is I was at a boat show last week, and this is one of the big questions that comes up. And I'll tell you that better talk to your insurance company, because that if you have a problem, you have thermal runaway. This is the problem, the potential problem. I have to be careful of my words here. This is the potential. I've never seen a problem with overheating batteries, but the potential is thermal runaway. And when you're talking about a less expensive battery, you have to be concerned about the internal BMS. Look at the BMS ratings. Quite often with these less expensive batteries, their BMS is not rated as high. Their charge current's not very high. Their discharge current's not very high. And that's not necessarily a bad thing, but it will demand that you have several of them in parallel in order to provide current for an inverter. Inverters are large load. Quite often with these larger batteries, they'll have a BMS that can only charge at 50 amps and discharge at 100 amps. Or greater. So those are very important specs that you should look into when considering a less expensive battery. And again, the UL rating and your ability to insure it. So those are really, really important. I'm glad you brought it up. Really important considerations when it comes to any lithium battery. Okay.
Any more questions?
I got one.
Sure.
Who makes that class T switch with the fuse on it? Fuse with the switch on it?
The question is who makes the class T fuse with, are you talking about the class T or the one that he showed?
No, the class T with the switch.
So the class T with the switch, who makes it?
Oh, I've never dealt with it in a single assembly. I've always had a battery switch and a separate class T holder. I do not know of a
Didn't he just show me?
No, that wasn't a class T.
Class T. Oh,
That's
that-
not
That was a
class
mega
T.
fuse.
Okay, all right, never mind.
Any other questions?
Well, no battle-born,
What's that?
battle-born batteries.
Battle-born batteries?
Battleborn Batteries has recently had a problem. Is that what you're referring to?
Yeah, just so everybody knows. That they are inexpensive.
He said, he just wants everybody to be aware of them.
Right. I understand that was the 100 amp Group 27 series only that had that production issue. Now, I'm a Battleborn dealer. I'm an approved Battleborn installer. And I'm very concerned about it as well. I know the gentleman Will Proust, I believe that's his name, did a YouTube blurb about it, discussing their production issues. And correct me if I'm wrong, but I believe they had a production issue, the loose connections, and they caused heat. And the last thing you want is heat around a lithium battery. So it's a very serious concern. I believe they've acknowledged the issue, but I also believe it only applies to a single model in their production series. But it's a serious issue, and you've got to be very, very careful about it. I don't know of any instance where they actually caught fire. I actually seen the outcome or the product of their problem with the loose connections. Naturally, when you have a loose connection in a high current circuit, you have a voltage drop, and the byproduct is heat. It's a huge concern, and it certainly is killing their business. They are really hurting, from what I understand.
Is there a known and agreed upon gold standard of lithium batteries? I mean,
Victron.
I mean,
The Victron, there's several things to consider when it comes to lithium batteries. There are some very, very well made, and Lithionics down in Florida is an American manufacturer. They assemble, of course, the cells are all made in China, but they are a manufacturer in Florida, and they have a UL battery. It's made in a metal case. It meets the highest UL standards, and they also are the most expensive. There's another type of lithium battery, solid state lithium battery, and that's the name of the company. They're near you. I think they're in Massachusetts. Extremely safe. They are very different as to compared to the lithium batteries we've been discussing. They are a solid electrode between the plates, and therefore extremely stable, extremely safe. You'll see and they are crush protected. You'll see some videos that they have on their website. They crush this thing. They drive nails into them. You don't dare do that with a LifePo battery. With that, they are extremely safe, extremely expensive rather. So if safety is your main concern, go to solid state batteries. Again, that's the brand name. I'm hoping to become a dealer for them. I'm not at the moment, but there are definitely companies with better reputations. Battleborn had a great reputation until this came in. Now, mind you, that the gentleman who posted this video, and I'm not a big YouTuber and stuff like that. That happened to be sent to me. He was a great proponent, and in the beginning, he took money. He acknowledged that he was paid to promote their batteries in the beginning. So it's
Chris, there was a question as to what was the name of the battery, the brand of the battery?
No, there's a video out there that has anybody watched that Duracell redoing that sailboat? He's put in solid state batteries, and there's a link that you can go to just to see what they do to the batteries on solid state. He was talking about, but you can access it through the last episode of the Duracell YouTube channel, where he puts the solid states in and then links you out and says, and this is what they did to him. Then, taking a drill bit and drilling them through and everything else was pretty wild.
amazing. Yeah, absolutely amazing.
Chris, we got another question here, George.
Is there any battery chemistry coming up in the future that looks promising?
I can't speak definitively of future designs. You have to forgive me. I'm a small business, and research and development is expensive and time consuming. I'm a small business where I'm quite often driven by demand. I think you can relate to that. It's I was very slow to come to the lithium market, years and years ago, until I really my customers started demanding it and were really inquiring about it. So it's I was slow to come to it because, again, from the just didn't know a lot about them. But it's been at least 10 years since I started installing lithium batteries.
Yeah, Chris.
The actual number of thermal runaways compared to the number of installations is extremely low, correct?
Yeah, absolutely.
Yeah, so, there's a lot of stuff on the web about thermal runaway, you're gonna burn a hole in your boat, you can't put it out, blah, 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 but if it's installed right, it shouldn't happen.
Absolutely. I agree. It shouldn't happen. The occurrences are extremely low that I know of, and it all comes down to what we touched on earlier: is the BMS and proper installation. You can, for instance, if you put one single 300 amp hour lithium battery and you're running a large inverter off of it, and you're drawing, approximately 300 amps out of that battery, it can do it, but it's going to get warm. And you're going to be testing all these. You're really putting the junctions, the internal junctions. They have bus bars across the cells. You're going to be really putting the junctions to the test. You will likely you will shorten the life of it. So the heat is not only the junctions, but it's the internal ability of the electrons to transfer in these cells, and that's what they talk about. It's the lithium batteries. Anytime you're doing the research on this, lithium batteries are extremely energy dense, and their ability to do high current, transmit high current, is great. And they'll do it as long as you let them. You put the loads on it, they'll try to do it. But the product is heat. So you've got that aspect, but also the mechanical aspect of these bus bars, and then you're exposed to vibration, and all this stuff can be compromised as time goes on. So there are also things. Those are the considerations when it comes to installation. Your battery bank should be, if you're going to be having an inverter on there, you should have, I like to have at least 600 amp hours, certainly greater than 400 amp hours. You want to be able to draw that current, especially if you run an air conditioner. And we have got plenty of installations that run air conditioners. And you're drawing that high current for long periods. You want to make sure you've got a properly sized battery bank, so you're not really putting those individual batteries through their paces with high current draws.
All right. Any other questions for Chris?
Fantastic.
Chris, hold on. What?
What about these new power packs, battery power packs that are charged through small solar panels that we put on boats now?
Yeah, like the blue eddies and the Jackeries.
Yeah.
There are different UL standards for those. I love them and I hate them. I love them because they're so compact, and they're handy. I've got some little ones that I use. I hate them because I don't sell. And I'm half kidding about that, but I have plenty of customers. So you think about the compactness and the convenience. I've got a lot of. I don't like them on boats because they are not. You can't bond them properly, and they're against ABYC. It's like a generator. Generators on boats, little portable generators. That is. Forgive me. Be clear about my statement there. Portable generators aren't allowed because they're not bonded properly. And the same thing with these Blue Eddy and these Jackeries. They've got their neutrals are not bonded to their chassis. Their chassis are quite often plastic. So you've got a floating supply, and the potential for a shock is great. So that's the downside of one of those little systems. They are inverter coupled outputs, and they are not. They're not bonded to anything. So that is the the downside when it comes to the safety side. They are against ABYC.
Any other quick questions, Chris? Chris, was there anything else you wanted to touch on?
When it's regarding I'll do my little sales push here.
Yes.
Don't hesitate to call me. Number one, I think Peter can vouch for my support, and especially if you're replacing something. But if you're a do-it-yourselfer, that's who I deal with all the time. I've been doing this a very, very long time, and I've got a tremendous amount of experience I can share with you and make sure that the installation is done correctly. Now, regarding if you're doing whole installation yourself, I was researching this last night. Look at abycinc.org. You will and at the top of the screen, the top of their website, it says find a qualified technician. They have great training and certifications that they issue people from every application from your air conditioning to your engines to electrical, plumbing, etc. For boats. And you can look up. There's an electrician. There's two of them very close to you guys. One is closer to Narragansett, and the other one is maybe closer to New Haven, but they're closer than me anyway. And maybe they'll come out to you. There's also a Victron installer not far from you. Go to again abycinc.org, and also Victron Energy. You can go where to buy, and he is a qualified installer. Now, the prices that I gave to Peter was a very small selection of devices, the most common devices that I sell on boats for smaller systems. They were 30% off. You're not going to see that anywhere. I'm granting that to you guys in hopes that we get at least $2,000 worth of sales. That means 10 people buy $200 worth, or 20 people buy $10 worth. I'm sorry. You know what I mean? My math is off by a zero there. So they are extremely good prices. I'll grant those discounts for everything that Victron sells. That is through the end of this month. And it may extend further, but I get quarterly updates from Victron. And the end of the quarter is March 31st. So I'd love to do business with you. And I can also provide Blue Sea equipment, Xantrex equipment. And also, I hope to be selling those solid state batteries very, very soon. I don't think they'll have any problem with selling to me, and I'll be able to offer those. But they are very, very attractive, a lot more expensive, but extremely safe if that's a main concern of yours. Go ahead, Peter. You're going to say something. I'm sorry.
Yeah, contact info. So, Chris, you want to give them your information? You can do it. They can write it down.
Yeah, you can get everything on my website, which is tekrispower.com, TEKRIS power.com. And you can see my phone number and my email there, but my cell is 732-597 8534. Peter has that as well. He's got my email as well.
So, Chris, what I'm going to do is we're going to print right now. Matt's going to send it to the office. We're going to print out that price sheet that he gave us. That's got his name and his phone number.
Okay.
It's got my address on it because he had my address, but that's fine. So we can hand those out to everybody. How's that, Chris?
Just real quick, does that show prices or?
That shows the limit.
But does it say that you said Blue Seas, and what else did you sell?
Xantrex, Blue Sea.
Okay.
Yep.
All right, that's Blue Sea.
Yeah.
I did have one question about solar panels that I forgot to ask. If you run them in parallel, can you put a 100 watt and 200 watt in parallel to feed into one of these chargers?
You can, but it's very important that their open circuit voltages be the same. I don't recommend it. I'll start with that instead. I don't recommend it because what happens typically is the voltage is like water pressure. When you have two devices like that in parallel, one will back bias the other. It's like each of them have, like we discussed diodes. They have output diodes, and a diode is a one-way valve. And when the voltage is greater on the one circuit, it'll back bias the other one. In other words, the other diode will is like a check valve, and it won't let the voltage come out or the current come out of that lesser solar panel. So most likely you won't get any production. Only during heavy load periods, they'll help each other out, but it would probably be the lesser panel will probably be diminished. So it's not a good idea. Just from a economy standpoint, you're wasting your money. So try to avoid that. Try to keep similar panels with the very, very similar ratings. Best to get the same model numbers, etc. Quite often these panels are discontinued, so I understand it's hard to do. So if it's if by all means look at the specs, open circuit voltage, and is critical. Otherwise, you just back bias the lesser one. Again, it won't produce.
Great. I think that's all we got for questions for now, Chris. I can't thank you enough for putting this together for us.
Well, I appreciate it, and I hope I didn't bore you too much. I know I tend to drone on, but I appreciate the opportunity very, very much, and I hopefully I look forward to hearing from you. And don't hesitate. I usually answer my phone 24/7. If I don't, it's because I got some family obligation, etc. But I wish you the best spring, and let's hope warm weather comes soon.
Thank you, Chris. I just want to, when I told some of you how I met Chris. I had a Xantrax inverter that went bad last year, and I called him up because he was listed as Xantrax, and he said I can sell you a better inverter, cheaper. And he did, and he walked me through the process. I can attest to every single time I called Chris, if I've got his voicemail, he's got back to me within an hour. So, you can buy his stuff online, but you have the brick and mortar experience, the service. So,
on that subject, call me. Don't buy it on my website. It's every is work progress. I love the people, and quite often we can do design, and I can make sure that we're getting the right thing. We consider a design, but call me. I think that's better.
Hey, does the price sheet show the 30% off?
I believe those prices were already the 30% discount, correct?
Oh yeah, that shows the 30% discount. I invite you to compare.
Okay.
Yeah. So the only other thing, while he's on here real quick, I can attest, I think Tony, Chris, there's a couple people that are on Block Island. We installed my solar panel. I already had the inverter and the batteries in, but the solar panel, we installed the exact solar panels that he's got in probably about 2.5 hours. Total. That was setting the panel on the top, running the wire down, tying in the battery, and having solar hooked up. So it's really, and I can't say enough good about it. It's unbelievable. I'm so happy. It changed the way we vote.
Felt like 4.5 hours. I think we helped them.
I set myself on fire. I set myself on fire as a handicap. So
Almost 2.5 hours, Tony.
anyway,
To put them out.
thank you, Chris. Thank you very much. Name of his company. Can you just repeat the name of the company again?
Tekris Power, TEKRIS Power.
Yes. And it'll be on that price sheet.
Okay, good.
But I want to just again say that price sheet isn't limited. That's just the common stuff that you're gonna need. He has a bunch of other stuff too, so reach out to him.
There's 5,000 Victron items.
Yeah, well, so
You don't have those pockets.
Chris, again, thank you very much. We really appreciate your time. Thank you.
Thank you.
Thank you, Peter. Bye-bye.
Thank you, Pete, for putting it on. Yeah.
Thank you, Chris. We'll touch base soon. Thank you. I did, but it's the same thing. He's getting a better price on anything I do.